All right, guys, and I got this test 14 review. First four are graphing functions, trig functions, so let's go to it here. Don't forget when you have a tangent that the asymptotes usually go at negative pi over 2 and positive pi over 2. So probably the easiest way to graph this thing is to take the x minus pi, set it equal to positive pi over 2, and also set it equal to negative pi over 2. And that's going to tell you where your asymptotes will go. So if I move that pi over there and add it to pi over 2, that's going to be 3 pi over 2. So one asymptote is going to be 3 pi over 2. If we do the same thing over here and move that negative pi over, becomes positive pi, which is going to be just pi over 2. So my two asymptotes, one's going to go at positive pi over 2, and those are going to go at 3 pi over 2, which, to be honest with you, those are the same asymptotes as usual. They've just been shifted over pi to the right. So asymptote there, asymptote there. The 5 in the front really means, halfway between the asymptotes where it crosses the x-axis. If you go halfway to either side, the vertical stretch in front tells you how far up and down you should go from there. So 1, 5, negative, 5 that way. So the curve looks like that right there. All right, part B is cotangent. Cotangent, the asymptotes are usually at 0 and pi. Hope you caught that, 0 and pi. So I'm going to do the same thing I did last time. I'm going to set what's in the parentheses, the x plus pi over 4 equal to 0, and also the x plus pi over 4 equal to pi, because that's where the asymptotes are usually. If I move that over there, it becomes negative pi over 4, which is not a surprise because, the plus pi over 4 inside shifts everything left pi over 4. And over here, if I move the pi over 4 over, I'm going to get 3 pi over 4. So when I draw my graph here, I'm going to have one asymptote at negative pi over 4, the other asymptote at 3 pi over 4. That's where the asymptotes are. And because it's cotangent, it goes the opposite direction of tangent, so it's going to do this kind of thing right there. All right. The third one, cosecant, negative 2 cosecant. Remember, cosecant's reciprocal of sine. So what I'm really going to graph is I'm going to graph this first. I'm going to graph y equals negative 2 sine x. The period's still 2 pi. There's no shift or anything, so I'm just going to go 4 ticks to 2 pi. Pi, there is a 2 in the front, so I'm going to go up to 2, down to negative 2. And I'm going to change colors and go really light here. Sine starts at 0, goes up, down, but because there's a negative in the front, it's going to go down, down, like that. And remember, your asymptotes go wherever your graph touches the x-axis. So there's an asymptote, there's an asymptote. And your graph, the answer to your cosecant graph is going to be that black section right there and that black section right there. All right, where you flip the sine graph. Think about it. Sine and cosecants are reciprocal, so you flip the sine graph to get the cosecant graph. Same thing on this one, except it's got more stuff, obviously. It's secant, so I'm really going to graph 3 cosine of x plus pi over 2. Let's just go through real quick. First of all, the amplitude is going to be 3. The period is 2 pi divided by b, which is just 2 pi this time. The phase shift, which it does have one, is negative pi over 2. So that's right. Remember, phase shift, I should have put PS. Phase shift is where you start your graph. So I'm going to start my graph at negative pi over 2. Know that for a fact. Then to figure out where to stop my graph, or where the period ends, I'm just going to take the x plus pi over 2, set it equal to 2 pi, and that's going to tell me where to stop the graph. So if I take that over to that side, that's going to end up giving me 3 pi over 2. So it means my first tick is going to be negative pi over 2. My fourth tick, where I stop, is going to be 3 pi over 2. Now, halfway between those two is 1 pi over 2. Now, that's going to be the second tick because it's halfway between, which means the y-axis is a tick, and there's a tick right there. Now, I'm going to go up to 3, down to negative 3. This is cosine. Remember what cosine does? Cosine starts at 1, in this case 3, goes down, up, just like that. So I can draw an asymptote wherever the graph touches the x-axis, which is there, and also the y-axis. So my solution, my secant graph, is going to be flipping the yellow cosine graph. Just like that. All right, keep going. Number 2, find the exact value of inverse tangent negative square root of 3. Remember, inverse tangent and inverse sine, you got to use quadrant 1 and quadrant 4. Your answer must be between negative pi over 2 and positive pi over 2. And because it's negative, I'm going to use quadrant 4 here. And because there's 1, 3, I'm going to say it's negative pi over 3. Number 3, let's work inside out. I'm going to leave the cosine here for a second. It's asking me inside, where is sine 0? Sine is 0 at 1, right? At 1. So now I'm doing, sorry, let me start that over again. That was bad. I'm sorry about that. This is live TV. Sorry about that. Can't go back and edit. Could, but I'd start the whole thing over, so not going to happen. Okay, so work inside. Where is sine 0? Sine is 0 at 0. And then it's asking you, what is cosine of 0? It's 1. So if you want to read the problem like this, it's really saying, what is cosine where sine is 0? What is cosine where sine is 0? And that's kind of gives you the answer. All right, number 4. Write the trig function in terms of sine and cosine, then simplify. So this is going to be fun and exciting. Let's try this real quick. I'm being serious there. This is good stuff. Okay, so tangent squared is really sine squared over cosine squared minus, and secant squared is 1 over cosine squared. All right, this is going to be crazy here. So they already have the same denominator, so I'm going to make a one big fraction, cosine squared. On top I have sine squared x minus 1. Now, sine squared x minus 1 is intriguing because the fact that, well, let's do this. This might be easier. I'm going to leave the top the same, sine squared x minus 1. Remember sine squared plus cosine squared is 1? That's on your identity page. Sine squared plus cosine squared is 1. That also means that 1 minus sine squared is cosine squared. Okay, so I'm gonna replace this cosine squared with 1 minus sine squared. Now, if you look at the top and bottom, they are exact opposites, which means you can cancel them as long as you put a negative 1. So boom, boom, negative 1. There you go. I mean, you got to admit, that's pretty good stuff. Number 5, simplify the trig function. Okay, remember the strategies I gave you, and you just got to find one to go with it. Remember, one strategy is not sit and stare. Don't sit and stare, so try something. One strategy is just change everything to sines and cosines. That's what I'm going to do here. Secant is 1 over cosine, and cosine is just cosine. And then tangent in my denominator is also, well, it's sine over cosine. So now if I look at the fractions in the fraction, the denominator is cosine. So what I'm going to do to get rid of the fractions in a fraction is I'm going to multiply the top and bottom, every single term by cosine. The first term, this cosine would cancel with the cosine and give me 1. The second term, I'm going to get cosine squared, which is what I was just talking about a second ago. On the bottom, the cosines cancel, I would get sine x. So there's the first step, right? So, and something needs to go off in your head when you see a 1 and a cosine squared. Look at your sheet, or your identity page, and think about sine squared plus cosine squared is 1, what that means. So if sine squared plus cosine squared is 1, 1 minus cosine squared is sine squared. So I'm going to replace the numerator, which is sine squared, over sine x. Sine x goes into sine squared, sine times, so that's just sine x right there. That is awesome. Okay, number 6, 7, and 8. Prove that the following is an identity. Now, the good thing about these is you know it's going to work. You know you got to take the side that looks more difficult, make it look like the side that looks a little bit easier. So I'm going to take my left-hand side and try to make it look like secant, cosecant. Okay, so let's start with the tangent. One good strategy, again, is change them all to sines and cosines. That's sine plus cosine. Sorry, sine x over cosine x. Cotangent is cosine x over sine x. Now I'm going to add those together. Remember a shortcut I taught you? When you add fractions, you just multiply your denominators like that. And your numerators, then to get your numerator, just cross multiply. So I'm going to do sine times sine, sine squared, cosine times cosine, cosine squared. Oh my goodness, do you see what I see on the top? Sine squared plus cosine squared, that's 1 over cosine x, sine x. Now one more step here. Sorry about that, I don't know what just happened. Before you just say, oh, I see it, and I do. Yeah, hopefully you can see it already, but you got to show that there's a secant. So I'm gonna break that fraction up by writing it like this. That's really 1 over cosine times 1 over sine. That's what that fraction is. That's just taking the fraction apart. 1 over cosine is secant. 1 over sine is cosecant. And guys, there it is. That's darn awesome. Okay, let's go to number 7. Number 7. Wow, we got 2 fractions added up, and it equals 1. That's not an 18. That's actually a 1. That's a long story how that happened. So I'm going to do the same type thing. Let's see. On the I'm not going to add these together, I don't think. No, I don't think that's a very good strategy. So I'm just going to break it down. I'm going to say this first fraction is cosine x over 1 over cosine x, plus the second fraction sine x over 1 over sine x. Now I'm going to take each fraction individually and do what the fraction bar says. The fraction bar says keep change flip, right? It's division of fractions. Think about this. If I keep the top, change that to multiplication, flip that to cosine over 1, I'd be doing cosine times cosine, which is cosine squared. If I do it here, I'll write it out this time. If I did keep change flip, I would change the division to times. I would flip to the fraction on the bottom. So it'd be sine x times sine x, which is sine squared. Guess what sine squared plus cosine squared is? You guessed it. It's 1. Number 8, last one of these, says sine squared plus cosine squared plus tangent squared is secant squared. This one looks awful. It's the easiest one yet because hopefully you see this right here. Hopefully you see sine squared plus cosine squared. Anytime you see that, that's 1 plus tangent squared. And guys, once you get 1 plus tangent squared, actually let's do this. 1 plus tangent squared would be 1 plus sine squared over cosine squared. If I add those together, 1 is really sine squared over sine squared plus sine squared over cosine squared. I shouldn't have done that either. Sorry about that. I did it again. I need the denominators to be the same. Sorry about that. It's going to be cosine squared over cosine squared. That's what 1 is. Sorry about that. So it gives me this. On the bottom, it gives me cosine squared. That's my denominator. On the top, look what it gives me. Are you kidding me? It gives me cosine squared plus sine squared. Guess what that is? You guessed it. It's 1, which is 1 over cosine squared. But you know what that is? Look what I'm trying to get. It's secant squared. Unbelievable. They always work. All right, turn the page. Measure what's happening here. Number 9, find the 6 trig ratios. Okay, this one should be one of the easiest ones you have here because that's just SOHCAHTOA. But you do have to find the third side. You do Pythagorean theorem, and you're going to find out that side over there is 9. Okay, so it's a 9, 40, 41, the old famous 9, 40, 41. Be careful how you write your stuff here. Sine theta is opposite over hypotenuse, which would be 40 over 41, which means cosecant theta is 41 over 40. Cosine theta is adjacent over hypotenuse, 9 over 41. Secant theta is reciprocal. I'm not sure why this keeps doing this. I'm sorry about that. 41 over 9. Tangent theta is sine over cosine. So I'm not going to worry about the triangle. If you do the triangle, you're doing opposite over adjacent. Cotangent theta is reciprocal of that, 9 over 40. And number 10, solve without your calculator. Now, technically, I guess you could use your calculator, but it's not going to give you the right answer. I want the exact answer. So cosine of 30 degrees, one that you should know. Cosine of 30 degrees is square root of 3 over 2. Then I'm going to square it. Sine of 30 degrees is 1/2. Then I'm going to square it. If I square the first term, that gives me 3/4. If I square the second part, it gives me 1/4. If you subtract those, it gives you 2/4, which is just 1/2. Do not expect it to work out quite that neatly in your test tomorrow. It could, but there's a good chance that it won't. Just follow your order of operations, get your values correct, and do your work. I got to make a statement here too. Here, I do not have my calculator with me for 11. But I'm going to set it up. Okay, so that's the best I can do for you. I hope that helps. If you need me, I can do it for you when you come into class tomorrow, probably. First of all, I'm looking for opposites. You know what? I see angle A and side A. I see the 120 and 45. So I'm going to say sine of 120 over 45. And then what else I know is I know side C. So I would do sine of angle C over 36. And obviously I'm going to cross multiply. And don't forget to, when you solve this, you have to do inverse sine to get angle C on your calculator. And then once you get angle C, I'm going to make this up. No, I'm not. Once you get angle C, you subtract it from 180 to get B. You would do 180 minus angle C minus A. And that's going to minus 120, I should say, for A. And that will give you angle B. And then to find side B, you're going to do sine of 120 over 45 again equals sine of whatever B was over little b. Okay, that's going to give you little b's right there. That will give you that size. So you got to find all three of those answers. I'm sorry I didn't bring my calculator home, so there's no way to do that in my head. So sorry about that. I hope this helps. Watch as much as you need to. Not hardly much review on this one. Come see me if you need to before the test. Hope you do great. See you tomorrow.